Welcome, everybody, to Chips and Tips. I'm Justin Gray from Toolpath, and with me today is
Chris Zappettini.
the one and the only.
Yeah, we're together but separate.
Right.
It's fun.
We are located together in Cleveland, but I need to up my recording game, so we're recording from different rooms anyway.
Yeah, I'm like the one time where I'm like, God, should I bring the Roadcaster with me, you know?
Yeah.
And I mean, to be fair, I don't think either of us thought I was going to be in Cleveland today.
Right. Yeah.
You know, or even at all.
Right.
Really.
Wasn't the plan.
Was not the plan. Not even fucking close. I was supposed to be in New York today, but it's a good reason I'm not. Like, we just kind of crushed, but yeah, here we are.
Well, I think that is actually, believe it or not, a good lead into our topic today, which is a mantra that you talk about quite often. Good parts, then fast parts.
Right.
First we make good parts, then we make fast parts.
Right.
And I mean, that obviously applies to cutting, but I think in your case, it applies to iterating on your business model. And we have all kinds of stories to talk about where it applies elsewhere.
Yes. Do you want to start with my business model?
Yeah, I think so.
Okay.
Yeah.
Cool. Yeah. So, like, I mean, you're a big part of this most recent iteration. You know,
Okay.
you helped quite a bit with I talked about this on the last episode of With Intolerance, that we were like, just like, as I was driving to Dillon, you and I were talking about the API for Asana.
Right.
And then I think the next day or something like that, or maybe 2 days later, we and I say we knocked it out. I watched you basically knock it out, you know?
I mean, you were testing. You were the
yeah.
tester, quality assurance.
Yeah. And so, like, the feedback loop was like pretty cool, because it's like, oh, is this what you want? Is this what you want? Yada, yada. And we like ultimately landed on something, but like it'll be 5 years in September that ZC's been going like full bore, you know? And we've changed, like, we've always had Asana, always had like QuickBooks and whatever else, and used Google Docs for proposals or whatever. And so, like, the thing that the biggest thing that changed was we were trying to be like very bespoke about the service that we offered, you know, which is like fine. And we're still doing that. It's just that we were like, the whole thing was bespoke. The whole system was bespoke, like everything. So we treated every customer like individually, and then, which is like fine. I mean, that's how you're supposed to do it. But like at the customer service level, not at the system level. And we were treating them uniquely at the system level. And that was fucking problematic.
Right.
Cause it's just like, it just made things kind of messy. And like, because there wasn't really a system and I wasn't super duper committed to it ever, we would build something and it would degrade, and we'd build something and it would degrade, and we'd go long stretches, especially if it was just me, like, doing basically nothing in Asana, you know?
Right.
And then
I think that's the good parts here, right? So the mantra is good parts, then fast parts.
Right.
So you spent 5 years like looking for the model that was good in Asana for you. And each time getting a little bit better, but never quite being fast.
Right.
And then recently what happened was you were like, okay, I found a model I really like in Asana.
Yeah.
This is good, right? And you iterated toward that. You talked about it with Intolerance, but the multi-tenant architecture, which is like a little baby project, a little baby Asana for every individual project.
Correct.
And so only then were you ready, once you were happy with that, once you were like, okay, this is the one I like. And in your case, it took you 5 years to get there.
Right.
Only then is it worth like iterating toward fast.
Yes, correct. And that's where the API comes in so handy, because like the Python script using the Asana API comes in so handy, because it's like we can fire it off, you know, type in, much to your chagrin, the customer name, and then it just like creates a new team, and all the projects are there, all the sections are there.
Much to my chagrin.
Yeah, because you were like, I don't want to fucking do this. I mean, you didn't say it like that, but Like this is improper. It's like, just give me what I want. Come on.
Yeah. I mean, it was like, just for the listening audience, there was like a way to provide input to the script. And I would have like hard coded it into the file, and you wanted to like add it as a command line argument, like a macro argument. And I was like, I don't really want to add it as a macro argument.
Yeah.
But we did it your way because you're the customer.
Yeah.
Right? So.
Yep. And then the other thing that unlocks this way of, because it's like a two-hander, you know, in terms of like good parts, fast parts, is how we do projects as well. And we've iterated on that side a lot more than we've iterated on the Asana side, I would say. I mean, the biggest thing, like most recently, was the retainer stuff. You know, we were doing the retainer, which was successful, kinda. Like it, but it was cleaner for us, kind of, but not as clean for the customer, because it's like it's $2,500 a month for 15 hours, and then like how many hours are left, and yada yada, and then like what are you working on beyond that? And we didn't really have any system in place for that, you know. And then if we needed to buy stuff or travel, that was separate. Blah, blah, blah. And then turnkeys were handled completely differently. And that was like fine, but all of it was just a clusterfuck. It was too many different ways of doing projects and things like that. It wasn't very clean on our end or the customer end. And so what we ended up doing is what we're doing now, which is like seemingly very successful. Like I talked to Michael Morton, like we talk like every day, and it's been going well for like a couple weeks now. And it's like, when's the other shoe gonna drop? You know, it feels like it's too good. Like the pipeline's full. Like we have like a lot of work currently, and we have a lot of work coming in as well. So it's like, it's very interesting, because it's like, this is, and we can just like, oh, you need something? Boom, fire off proposal, fire off. Everybody's getting the same fucking thing, you know, which is.
Well, I think that brings you back to like, you found a system you liked, and then worked on speeding it up, right? And
yes,
the good parts, then fast parts mantra is like, instead of trying to be really fast, which you've done in the past, like, let me just answer everybody instantly, and I'll handle everything like it's a snowflake. Now you have a very standardized, uniform process that works for you. And then you could focus on speeding it up. Right. The through line between for all of what we're going to talk about tonight is that like you focus on getting high quality things first. Right. And this is a philosophy for almost anything in how you build your shop. You focus on getting good quality parts first, and then you worry about speed, because otherwise going fast with bad parts is just like wasting resources. Right. You're just amplifying mistakes.
And the other aspect of that is like spending a fuckload of time trying to optimize the perfect system, or perfect process or whatever, before you've cut a single chip, is almost always going to result in just like a ton of wasted time. And there's always going to be some asshole. We've talked about this, like, well, that's how I do it, and it works really well for me, and blah, blah, blah. And it's like, fine, okay, that works for you. But like, that is the exception, not the rule. Because I've personally worked on projects that we spent weeks and weeks and weeks and weeks doing all this like minute testing of like this, and it was like not exactly 1-to-1. Like the machine was different, the work holding was different, the coolant system was different, and it's like, oh well, once we like we did all this testing, so once we go to the actual system, it'll work. And like we might as well have done nothing for like all those weeks. It almost like we learned zero.
In software optimization, there's a famous saying, which is premature optimization is the root of all evil. Yeah. I forget who said it. It was the guy, I think it was the guy who invented the LaTeX programming typesetting language. Anyway, but the point there is like, don't bother optimizing your code until it works and works well, because you don't know what you think you know, but you don't know where the bottlenecks are. Right. And you could just be wasting your time, right?
Yeah, you gotta live in it. You gotta like live in it. I mean, like there are things we want to change to like the Asana script and stuff, and like, and but we're just kind of living in it right now to be like, is this how we want to do this? You know, like, and so, I mean, so far it is like there's some like fairly minor changes we want to make just based on like the API's limitations, I guess, that we have to do some different stuff. But like if we had come out the gate there, I don't think we would have landed where we are now. You know, it would have been a mess. We would have just like basically ended up with a bunch of garbage, and then like where we were before, which is like a half-built system that doesn't work and nobody uses it.
So let's bring this around to like job shop. Oh, cutting. Yeah, we can go to cutting, right? Job shop work, cutting. So why? Like, why do we focus on good parts there? Like, what goes wrong if you try to make fast parts first? Give me some examples.
The biggest thing is like it's an interesting thing because like when we say fast parts, what we're talking about is a like dialed in process, you know?
Right.
And I think that's a like because you can go fast and not be optimized. You know what I mean?
Right.
So I think
you're worried about throughput.
Yeah. So it's an important distinction that like when we talk about fast parts, we mean like throughput wise and everything because we're always going to be like pretty fast. We're never going to come out like crazy slow. But the idea is to I mean, like we say all the time, like just fucking cut because you can tie yourself into knots trying to find like what's the right end mill, what's the right speed, what's the right feed, like do I do this little thing first or that little thing first, and like because the material might do this and the material might do that and yada yada, and like at the end of the day you're not going to know until you know because you can't possibly know. So you
all of that work, and then it turns out that the chamfer mill you chose is throwing a burr. Right. And the bottleneck in your process is actually that your hand's stoning each of the parts.
Yeah. And so it's like fuck. Yeah. So, and you can spend a ton of time getting there where, if you just started cutting and like, cause at the end of the day, the goal is to make money, right? So getting a good, reliable process onto the machine as quickly as possible and getting it off the machine as quickly as possible. Like, oh, now we're making money. And like, this isn't like a new thing, but it's like, now that we're making money, we can breathe a little bit, especially when you're doing, production work, and then go back and like, now we have a baseline. Now we can go forward and like, okay, maybe we change the roughing a little bit. Maybe we change the strategy. Maybe we can make the work holding a little bit more robust. Yada yada. Like, we made it out of aluminum because we didn't know if it was going to work. Now we can make it out of steel, which will increase our rigidity on the second operation. And so then we can push that operation harder. It's going to make it last longer. All of that, but like. You can start there, and I've definitely worked on projects where we started there, waited 12 weeks for the steel production tooling that's black oxide coated and like all the hardware's there and it's like engraved and yada yada, and then it doesn't fucking work and you end up modifying it anyway, where it's like we could have busted the same thing out in aluminum 12 weeks ago, 11 weeks ago, right? And had 11 weeks of process testing where we don't have anything now.
So the good parts, then fast parts. Another way to say that is like, how quickly can I screw this up and get past it? Like,
yeah.
How quickly can I make my first mistake?
Fail fast, fail often, baby.
Right. You know? Yeah. Because you don't know, like whatever you think the problems are, and maybe you're super experienced, but whatever you think the problems are, you probably missed something critical. Or you spent all that time optimizing it and some other problem turns out to get in your way anyway.
We've all experienced this, like and even people with a lot of experience that we like the thing that you end up tie yourself up into knots over ends up being a fucking cakewalk. And the thing that you're like, oh, that's going to be a breeze, just crushes you. And then you're like, then you're tying yourself up into knots anyway. But when it's an actual problem, and that sucks. And it's like you can just get there and just move and go and cut and like, and it's like there's like some obvious exceptions to this, blah blah blah, which is like if the material is crazy, you don't really you don't necessarily have that option. If you don't have like the ability to like scrap a bunch, but like we're not really advocating for scrapping a bunch, just getting good parts.
Make a test part in aluminum. Like if
Yeah.
you need an Inconel part, like cut an aluminum one first, right? Like,
yeah, just for proof of concept.
Yeah, or test your work holding or check your, right.
Yeah. And it's an interesting one when we think about it, like from that's just like general cutting. I'm just like checking the board. When we look at like from a job shop versus production, because this is always the argument. Yes, like the straw man of it all is like, yeah, you can do that when you do production, but you can't do that when you do job shop, which is true for an individual part on a part by part basis. But it's not necessarily true. Like you kind of move upstream at the job shop level to the process where you're trying to get your process dialed into, like, how can I get, and like we talk about, this gets talked about a lot with templates and everything.
The process here is like quote to ship.
Yeah, exactly.
Not like I have my stock and I want to put it on the machine, but like I get an RFQ, I make a quote, I order stock, I order tools, I get it on the machine, I cut the part, I inspect it, I ship it. So you focus on making that process really reliable, and then you worry about speeding it up.
Yeah. Yeah. So like, in that case, you're talking about templates and things like that. You're talking about a lot of different systems and like, how do I effectively quote quickly, which is like something I've personally worked on. Like, how can I get quotes out the door as fast as possible? Onboarding customers, if they're new customers, as fast as possible. And then the actual cutting aspect of it from the job shop perspective is like, do I have templates? Like, do these parts fit in my standard tool list? Yada, yada. Like, how do we get on these parts onto the machine as fast as possible, assuming you have like schedule and yada, yada. And then the shipping aspect of it. And like OSP, if you have outside processes to like clean everything up and then get it to your customer ultimately.
But even on quoting, we could say good quotes than fast quotes.
Right.
Because there's nothing worse than, like the faster you quote, the higher your likelihood of getting the job.
Right.
But there's nothing worse than sending out a quote that's wrong and you lose money, or sending out a quote that's too high and you lose the opportunity on the job when you could have had it. So like finding a way to give high quality quotes is your first job, and then you can worry about fast quotes.
Yeah. And that's interesting because like you kind of solve that problem a little bit, right?
We help. We give you more reliable information with Toolpath. Yeah. We'll help you not miss features. We'll help you make sure you have the right tools so that you don't get caught off guard.
Yeah.
Right.
And then,
but that's also why a lot of people rely on McMaster for stock, right? Because they can get high quality. Everybody has
with
fast
certs.
Shipping.
Yeah.
With certs. Yeah.
Like tomorrow. Yeah. And it's like, it's expensive and you pay for it. But if you quote appropriately with that stock in mind, then it's whatever. It doesn't matter.
Right. Right. So you touched on it a little bit, but I think there's an open question on like, do you even need fast parts, right? And we can talk about how it's not really tack time for the part. It's really throughput that matters. Like if you can cut a part in 5 minutes and I can cut a part in 15 minutes, but you're breaking end mills left and right and mine run all day, then 15 minutes wins every time, right?
Correct. Yeah.
But there's an argument to be made that you can almost reverse that process and like you make a good part, right? And you and Tim talked about this a little bit on an episode of Chips and Tips. Like if you don't make a part better than it needs to be.
Yes.
Right?
Yep.
And so in a sense, like good parts and fast parts could mean like backing off. Like, okay, I can go a little faster here, sacrifice surface finish, change something up, use a different end mill, but like reduce the quality of the part. Because your customer doesn't want to pay for more quality than they need, right? So
and in most cases, they're like stop, don't do that.
Right.
If you can get it to me faster and cheaper, do that, please.
Right.
Yeah. There's the like optimization of everything kind of only comes in at like certain quantities,
Right.
and the quantity and the part itself, because like we're working on this like turnkey right now that it's fairly low quantity. I think it's like 100 parts per year or something, but it's a huge Inconel part, and it takes them like 6 weeks to cut the part. Not like straight machine time, but like start to finish, each part takes 6 weeks, like from when the material enters to when the raw to when the finished part leaves. It's 6 weeks. So like at a low quantity, we like getting every little bit of time out of that thing kind of matters, because it's like that's a lot of time to be, and I think they do it on like 4 or 5 machines right now or something. It's just like very intense. So getting it down to like not even necessarily as quick as possible, but as easy as possible, is massive. To get it like flowing through the shop very, very quickly, is huge. It's massive. Like, and that's like a case of like the lower quantity. I guess what's a better way to put this would be the overall time impact of the run is going to be on your shop.
Right.
Because it could be like, yeah, I mean, you could have like in that case 100 parts that is technically 600 weeks of machine time that you just like, or that like, what do you do with that? You know, like that's a lot of machine time. And then you could have 7,000 parts that you can cut in 2 weeks.
But in that job, like 6 weeks means the cost of one scrap part is like crazy high.
Insane. Yeah.
So it doesn't matter how fast you could go if you're scrapping parts. So
Correct.
You make good parts first, and then you turn the dial on speed.
Yep. And like we talk about that like top to bottom in our process for doing turnkeys. Is like, oh, you're going to be optimized. It's like, we'll get there, you know, and like we might need to change work holding, but we need to like see like how the material, like another turnkey that we did get with these big like aerospace like bracket things, and they're going to move. Like they're just going to move. They're huge. We remove like probably more than 90% of the material away from them. They're gonna move, and it's like, can we do that? Will it be fine to just like crack the vise and like clamp it back down and keep going, or do we have to invest in like some FCS tooling that's like where you have like the floating deals, you know, and allow it to like float a little bit so that we don't have to like crack the vise and like reprobe it or whatever. We can just like crack the clamp, it'll reposition, then we can lock it back down, and then we're good. And it didn't actually like it removed the tension or the stress, but it didn't lose its location. But that shit's expensive. And so it's we're not going to start there. That's a crazy thing to do, is to start there.
You don't even know if you need it.
Right. We don't know if we need it. And so like we can possibly get, I mean, it could like, we could get into it and it could actually like, and I'm saying I know it's going to move, but we don't necessarily know. It's just based on experience. And like, it could just be a straight up 2-op part when it comes down to it. And we'll be like, cool, chilling, no problems. And there's only one way to find out. And we told them this, and they were like, cool, that works for us. It's like, we're going to cut, we're going to get going, we're going to make good parts, and then we'll continue to optimize the process as we go. That's part of the package, you know, is the optimization of it all. And then you end up with the files if you want to go further than that, and then we're done.
Another place this creeps in for job shop work, for me at least, is feeds and speeds. So I could say good presets and then fast presets.
Yeah.
So in automation, like your presets are everything, because the AI needs to just know what to cut with, right?
Right.
And so it's far more important for me to have reliable things that I know will work, right?
Mm-hmm.
And sure, maybe if, you know, this time the end mill's only going, you know, quarter of its diameter, and, you know, my feeds and speeds are like set to be reliable at 2XD for adaptive roughing.
Mm-hmm.
Could I be going a lot faster at that shallower depth? Yeah.
Right.
But it's not worth it.
Yeah.
And so first you have to get to a reliable set of feeds and speeds that you can just send on almost any part.
Right.
As long as the part's not shattering.
Yeah.
And then once you're stable, you can start tweaking and being like, okay, I actually use my 16th end mill way more than I thought. Let me go see how far I can push that one in. That's highest bang for my buck.
Right.
And so good presets and then fast presets, I think, is a mantra there too, of like, get everything stable, get it to where you can run. Like parts are moving through your shop. You're making money. And then you can afford to experiment a little bit and find some time.
Yeah. Yeah. I think another, like, this is a crazy one, but like, like I think about this where, in like a tool pattern, like the tool pathing of it all, and like some of the things that we've seen and we've discussed, like here making parts in the shop, is like, oh, it tricoidal this or it adaptive to this, and it could have just been a pocket. And it's like, at the end of the day, and like, this is something I really, really want to do, is take like we've talked about this, is like take the exact same part and like run it through toolpath, one way optimize it for the like correct way to cut it or whatever, and then the other way just like let it run, and what gets off the machine faster, start to finish, what gets me the good part, the one good part, and eventually, like, because if you're doing like 1 to 5, like maybe it makes sense. If you're doing 100, sure, optimize it, but at the same time, like, if I can get my reliable, like, this is like a more practical example, I guess, is like, if I can get my one unoptimized program running right now, then while the other one is going, while it's cutting, I could be optimizing and optimizing and optimizing and optimizing and driving the time down. And then
or quoting another job.
Because the other thing is, like, what's that table where you have to like, I can't remember the name of it, where it's like the amount of time that you put in to a thing and how much time you need to get out.
Is this an XKCD comment?
I think it is. Yeah. I think it is. Which is the thing of like, I mean, but it's pretty accurate of like, at a certain point, if you're putting in, like when we were riding around the bay this weekend with Flarg, like he was saying, there was a little toolpath that he spent 2 hours like just dicking with, to get it just right. And when he got it just right, it ran for 1:36. And you can fall into those fucking rabbit holes where it's like, that time would have been better used a million other ways,
I do know. I found the comic. I'm going to share the screen.
Cool.
Selecting a tab. Is it worth the time? There we go.
Yeah.
Sure. This one.
Yep.
Right?
Yep.
So how much time you shave off?
Yeah.
How often you do the task?
Yep. It's it's really good. Like, yeah.
Right.
It's like you have to be doing like some gnarly shit for it to be like really, really worth it.
And that doesn't even account for like when you can go do something else. Right?
Yeah. Right.
Although I will say one thing, so like this concept, I feel this in my bones, but one thing, as having made parts, one thing that changes it a little bit is automation on the machine.
Yeah.
Because if you have to stand there and tend the machine, like versus like, I could just load 5 pallets and now it's really not my problem.
Once you put automation on the machine, unless your quantities are like crazy high and you need to hit like a certain amount per day at almost any level, like just having the 2 extra unmanned shifts is like, unless your cycle time would literally have to be 3 times longer for it to matter, for it to matter, like, and then be almost in a negative, where because like we ran into this at Westcott with the lathe and the robot. I don't know what they're doing now with that, but they put it on, they wanted it to run, like we told them we were gonna have to mess with the programs because their chip issue was insane. Like they ran really fast parts, but it was like a bird's nest. Every fucking part that came off of that machine, like there was just chips on like every single tool in the turret. It was disgusting. So to get it to run overnight, we had to almost effectively like double the cycle time to get the chips to like a very reliable state. And reliable is like not running, because like there were times where it's like we had it we ran 10 parts. Oh, no chips. Cool. Let's fire it off. Then like 30 in. Now it's starting to build, you know? And that's like a really interesting thing about automation is like, you're not looking at like, oh, did this work once, twice, like 3, 10? You're looking at like, did this work 100 times? You know, 200 times, 500 times? Like, oh, are my tools starting to break down at like 700 and now my chips get really bad? And like, how do I account for that? And yada, yada. I'm getting kind of off in the weeds here, but the point is like,
well, I think it's important because when we talk about good parts then fast parts, like I had a job one time where every fifth part, like there was this little spindly like tong on the part, like this tong sticking up, two tongs, like a pair of tongs like this. And every fifth part, like exactly every fifth part, I'd break one of the tongs off.
Interesting.
And I was baffling myself. So I'd be like, I don't know what's going on. And finally I figured out that chips were building up on this one end mill. And every fifth part, the chips would be enough to break the tong. And then I'd go in there and be like, what's going on? And kind of mindlessly clean the chips off the end mill. And then it'd work for 5 more parts.
That's such a beautiful thing to point out is like that act right there is like the type of shit that people just don't think about when they go to like, oh, all I do is blow my vise off and that's it. Like I take the stock out, I blow it off and like, they don't think about the other, like the 50 other little baby tasks they do when they get in there. Like they actually picked up a little bit of chips and moved it aside and like pulled it off this and pulled it off that and whatever. And then they get the robot and 10 parts in, it's like, this thing is throwing parts around, you know?
Right.
It's like there's chips everywhere. What the fuck happened? And it's like, well, go ahead, let's go back to loading it manually and seeing what happened here. And then you find out, it's like, oh, it's like, nope, don't touch that. And it's like, but I always touch that. It's like, but you can't. Think like, you need to get it to a point. It's like, what if you were running the part and you just could not touch anything, which is fucking hard. It's way harder than you think it is because you just mindlessly go for it, you know?
So good parts then fast parts. If you're going to automation, you might have to add like a whole bunch of ridiculous blow off cycles and put a cool and flush tool and just spray the crap out of the fixture.
So like
it's really slow.
Yeah.
Yeah.
So like bringing it back to the lathe, we would run it and like there was like, because we had to pop a huge drill and like there was chips that would get stuck behind things, like we would take the drill and like just park it in like, we'd drill a little bit, come out, park it there, you know, do some boring, bring the drill back, park it, and just like we would do like OD roughing and then bring it all the way back to home to make sure that the chips cleared the tool and the part and the chuck and everything. And then come back in. And then when we would groove, we would do all this. And it was dog shit slow by the end because like it was double the time. But because we were able to run overnight and effectively give them 2 extra shifts, we made more parts per day than when they were running full tilt manually because you didn't need anybody there. Like, did they capitalize on that? Fuck no. But that's a whole different topic than what this is. You know what I mean? They did some like really dumbass shit, whatever. Like that's their own prerogative. But like but like we accomplished the goal and the cycle time was bad. But like there's this thing about like where people get really honed in on the fucking cycle time of things, cycle time. And it's like, it doesn't fucking matter. Like it does, like obviously it does. But at the end of the day, like how many parts am I shipping per day? How many parts are moving off of this machine per day? I mean, like that's the goal, like Eliyahu Goldratt, like the goal is, like if I get 150 parts off of my Haverly Robo Drill and then they go fucking rot in front of a horizontal somewhere else, what the fuck did that even matter? You know, like cool, it ran overnight. But did it mean anything? Like the parts just go sit somewhere else and like that's just like money sitting around that like we didn't need to run that fast.
So maybe we should change the saying to good parts then good throughput.
Yeah.
But
I do really, good parts, fast throughput. Good parts, fast throughput.
Yeah, good parts, fast throughput.
I mean, you think that'll fit on my knuckles?
I don't know how many good parts that then fast through, but
We could probably make it.
Yeah.
Yeah. I mean, if you think about it, you got the 4 up here and then the 4 down there. So we can make it work. Good, good part, fast part works, you know?
Yeah, there you
And then
go.
on my fingernails, I could do thank you for your attention to this matter.
Wait, can you tattoo your fingernails? That's a thing?
Yeah, I think you can.
Wow. Okay.
You can tattoo your eyeballs, you know?
That's awful. That's terrifying.
It's pretty bad. Like it's like 50-50 you go blind. And the thing that's wild about it is like, you don't go blind right away. You go blind like 6 months later. So you're like, oh, we're in the clear. And then it's like, there have been people that like got it done and then they're like, chilling. And like 3 months later, they get the other one done. And then 3 months after that, they go blind. And then 3 months after that, they go blind.
I don't know how to tie that back to good parts, then fast throughput, but somewhere there's a tie-in. Okay, so bringing it back around, we've talked a good bit about cutting, right? And it applies to the part itself. Like, don't worry about making high throughput parts until you can make good parts reliably.
Right.
And then you start turning the crank on throughput. We talked about it in terms of like automation and cutting. Focus on feeds and speeds that give you high good reliability, and then you can worry about that bottleneck.
Yep.
And we covered the difference between like an efficient process with high throughput and optimized feeds and speeds.
Yeah.
Templates fit in here a bit, right? Like
big time.
Yeah. So you can have like a really general template that will give you a good part reliably, but it might not be fast. It might not be highly optimized, right?
Right.
But the question is, do you need that part to be that fast? Or did you waste more time programming it than you would have saved running the template?
And this was like on the way to tacos with Flarg. That we talked about this a lot because I was like, I had misspoke and said your shit's not efficient, and that was wrong because it is efficient. It's actually like crazy efficient. It's probably the most efficient templates like in the world ? You know,
probably. Yeah.
Which is cool and it's good. It's like, but it's not optimized, and like it doesn't need to be. Like it really doesn't need to be, especially in like the environment that they're in. Is like highly it's just so bananas that at the end of the day, it's like they're gonna be making like a million of the same thing a bajillion different ways. So it's like here's one.
And that is I think one of the purest examples I've seen of like throughput is the only thing that matters.
Right.
They often only make like 5 or something, right? Like, yeah. But the only thing that the customer cares about is like, can I have it today? Yeah. Can I have it in an hour? Right. And like, as long as it's part shaped, they're still pretty accurate.
Part-shaped object. Yeah. And like you have one, a part-shaped object by Flarg, and it's like, and you're like, this was programmed in 2 minutes. And it's like, oh yeah, okay, that's hot. Like is it a perfect part? Absolutely not. Is it a passable part? Absolutely. Like, and that's what fucking matters. Is like, and I think back to the kid in Arizona who called me out for talking about him with intolerance once. But he also he had called me and he's like, because I yelled at him for like, there was one day where I just had enough of him, like, of tying himself in knots about, oh, should I do this and should I do that and whatever. And I was like on my way to Lowe's or something. And I was like, dude, just shut the fuck up and cut. Just fucking cut, dude. Like, you don't know. I don't know. This fucking dude in Florida, your best buddy, he doesn't fucking know. You know what the only way to know is to fucking cut. Just fucking cut the parts. And he called me like a couple weeks later and he's like, I'm getting a lot more shit done now. He's like, thank you. I lost the plot on that, but it's
good parts versus fast parts.
So this is the one of the first times I was helping him was like he was having trouble. It wasn't true position because like the parts that he was doing, it's all like linear tolerancing, and possibly like hold a hole like 1,000 is really it's really weirdly toleranced. It's fucked up. But he was like, well, it's in, and it's like he was having trouble hitting it because it was like ±1 for the whole positions, and it's like, okay, so it's like, are you spotting? No, I'm not spotting. All right, let's fucking get a spot drill. And he's like, oh, it's working, and he's like, it's working, but it's like 8/10, and it's like, okay. It's like, he's like, so I'm still fucking with it. It's like, why? It's like, well, I want it to be better. It's like, the customer doesn't fucking care. You did your job, man.
Right.
Like, just fucking move on. Like, it's such a silly thing to like worry about. It's like, your good part, like, this is the passable thing, is like, it's not like you're giving him a 1,000/1/10 part, a 1,000/5/10 part. You're giving him a in spec part. Like, just fucking move on with your life. You did the job. You did your job.
Well, I could turn that around and say 8/10. Like if you're trying to go faster, that 8/10 might not be enough margin, right? Mm-hmm. But that's the point. Like, good parts than fast parts. If you are making good parts at a high enough rate, then just like, unless your spindle time is maxed, move on.
Yeah.
Like there's no value.
Yeah. Anyway, like, we got off the templates. And so like, he wasn't working with templates, and it's like, but you do parts like this all the time. Why are you not locking this shit down? Like, this should be like, because there is, I mean, obviously with this type of stuff, you can have like very, very, if you're like send cut send, for instance, like, you're trying to build a template to be able to make any part, right? That basically fits within the work envelope of a man, which is a nigh impossible task, right?
Even for AI,
even for AI, it's just like, it's just insane. So like, and so like trying to create like a single template, and I think you end up like, before you can use something like Toolpath or whatever, you end up with like playbooks of parts, and then you're just like, you're dumping things into buckets. But again, like, good parts, fast parts, good process, like optimized process, whatever is like, start with the generalized one. You realize like, oh, on these parts, this is what I did. And on these parts, this is what I used from these templates. And then you start to like, they start to like, from one super template to like even more contained to like, excuse me, more contained to like optimized super templates, and down and down and down and down you go.
There's a really neat tie into that for AI, but it goes with good parts than fast parts.
Cool.
Let's say you never used Toolpath to program any parts.
Okay.
Just not interested, right? For whatever reason. So you start to build up templates, and you work on making really good templates for the 5 or 7 or 8, whatever kind of classes of parts. And you really get those dialed in. So you've got good parts coming from these templates.
Right.
And now you come to me and you say, okay, how do I make these templates faster?
Right.
I look at your process and I say, you don't need your templates to be faster.
Yeah.
You need a faster way to figure out which part goes with which template.
Right.
Because it doesn't matter. Like, your problem is you're not getting it on the machine fast enough.
Yeah.
Because you have to like try 5 templates.
Yeah.
So one of the things that I hope, it's not there yet, but I hope Toolpath can do is help you go and say like, okay, I have these 5 processes. Which process does this part fit into?
Right.
And so that's an example of good parts than fast parts. But the fast part, or the high throughput, it doesn't come from speeding up the template. It comes from speeding up the bottleneck before the template.
Correct. Yeah. So you like, yes, when you, goddamn, when you start to like hone your templates in, it's like, it's just like how you're essentially getting your time in front of the computer from like into your CAM system to out of your CAM system to as small of a number as possible.
Right.
And then like, ideally, like coupled with that would be your standard tool library and all that stuff, which is like, this fits into my standard library, ideally to a point where I'm doing as little setup as possible. And so like, you're using like lang vices and like, maybe you're just having the world, or like, if I'm doing soft jaws, it's like just prismatic shit. So I don't have to like do anything crazy or whatever. And like, you're just trying to like hone to make yourself like a weapon, right? Like, and you're just like, it's just like so little friction from like input to output.
I had a customer stop by the shop and they were talking about how they needed to go faster. Mm-hmm. They have an older machine. And they're like, I need my machine to go faster.
Yeah.
And I was like, well, like, do you have any payments on the machine? And they were like, no. I said, and then it turns out the machine's like in their garage, right?
Right.
I said, could you let it run overnight? And they're like, yeah. I said, then the speed doesn't matter.
Right.
All that matters is how fast you get the part on the machine. So like literally all that matters is that you get good parts.
Yeah.
And I said that he was like, yeah, but my setup takes me like 45 minutes because it turns out there's no tool setter. He's setting with like a block on every tool.
Yeah.
And I was like, then the only thing that matters for you to get fast parts is to buy more tool holders.
Right.
And like store the offsets. Like that's it. That's the only thing that matters.
This was Matt Sura's, old Matt Sura's.
Old Matt Sura, yeah.
Yeah.
Yeah. And a robo drill too, an older robo drill.
Cool.
But like the throughput of your part is irrelevant. Or sorry, the speed of your part is irrelevant because your throughput is governed by how much time you spent setting up that part.
Right. Right. So like really common work offsets so that you don't have to use the dial indicator as much and stuff like that is like you start to get very clever and like also understand like, this is why 0 points are so useful. Like 0 point systems and common offsets come in handy because you can just kind of like start to slap material in and just run. Like this is how I had my Matsura set up, is pretty much every tool was touched off the bed of the vise. And so if I needed to move up or move down or whatever, like we could make really easy adjustments in like the Z for the work offset and just keep going, And so like doing multiple setups became like very, very easy, and touching off tools is very easy because you're always touching everything off to the same spot. And that's like a little, I mean, it's kind of like 101 stuff, but it just it's what makes you faster when you don't have a probe or a tool setter.
And then you're not breaking down tools. You're leaving them set up.
Yeah. And then I was buying like cheap tool holders, because I mean, Archer, not the arrow, do as I say, not as I do. Like, I mean, we have Power Grip now, but at the time it was just all like Amazon or Haas, like,
I mean, you can get good results out of an ER holder.
Yeah.
It just takes effort. Right.
Yep.
And even that is good parts, then high throughput. Like, don't like,
yeah.
Like sometimes your problem is the holder, right? If you have some really nasty situation or something, sometimes you just need another holder. Yeah. But like getting a good part doesn't mean buying the best holder first. It doesn't always mean that. Sometimes that just means like, okay, now when like building tools becomes my bottleneck, that's when I need new holders.
Yeah. And this is something that I talked to Garrett Wade about, because he's got the UMC 1000 and stuff, and he's trying to like maximize the shit out of that thing, and it's like, or like move on or whatever to like a different platform, and it's like you can do that. Like he has taken, I think what he's doing on the UMC 1000 is like God's work. It's just like it looks so good. And it's like, should I move on to another platform? It's like, invest in tooling, invest in software, like tool holders, like try something else first. That's way, way cheaper. And then once you've like fully maxed out the 1000, then it's like, and then you literally like squeezed every ounce of performance out of that thing, then move on, because most of that shit is transferable, I mean, there might be cases in like the tool holding system where like the taper doesn't match if you go to like HSK, but it's like you can just toss those things away. I mean, not toss them, you sell them, right? Like,
they hold their value. Yeah. For
sure. And you'll be fine.
But I could turn that around though and say that's a case where sometimes, especially in a job shop, like Garrett's absolutely doing it the right way. Like his skills will translate. He'll get way more out of a higher platform because of all the work he's put in.
Yeah.
But at the same time, if you're doing high mix work, then getting good parts can leverage a machine that's very accurate, right? That can take a source of variance out of your process.
Correct. Yeah. But I mean, and then again, the other aspect of that is like, just because you have a very accurate machine doesn't automatically mean you're making good parts.
Correct. Right.
Like, so it's like, there are cases where it's like, oh, I'm having trouble doing this and doing that. And it's like, that's a you thing, brother. Like, should I buy this more expensive machine or that more expensive machine? It's like, I think you should look at your process. And like,
Right.
that's not ever a sexy answer to hear. It's like, maybe like, and we all struggle with this where it's like, no one wants to hear, oh, no, your machine is fine. You're just dog shit at what you do. And it's like,
Right.
I'm like, it's like, oh, ouch. All right. But it's like, but sometimes it just happens, you know, like you
Sure.
you fuck up. Like,
That's a version of good parts than fast parts, though.
yeah.
Be good at making parts on your current platform. Don't
Right.
spend money on a new platform to paper over
Cross your fingers.
Yeah. To paper over your weaknesses, right?
Yeah. This cough sucks.
We'll get you some tea after we record.
Baby. Yeah.
Okay,
Like
so
a raspy right now. It's like a little late night radio. What's going on, baby?
there you go.
This better stay in.
I'll make sure Ed makes it through the edit.
All right.
Okay, so I think we've gone through good parts and fast parts pretty extensively. The only topic left to cover is really like other analogies outside of machining.
Right.
Because I think it brings it around sometimes to take it outside your sort of normal area to think through it.
Yep.
So my favorite good parts and fast parts story is really about aircraft. And really it's about making some parts and then safe parts.
Right.
So for aircraft, like the most important thing is that it doesn't fall out of the sky. Like,
Right.
right. And so,
Yeah, mostly.
yeah,
That it gets into the sky and then it doesn't fall out.
Right.
Yeah.
Yeah. Right. But if you have to choose between those two, then you choose don't fall out of the sky, even if it means never getting into the sky.
Correct. Yeah.
Yeah. So I was working with a colleague back in my NASA days, and they were like, oh, we have to make this test airplane. And NASA has a very, very sort of rigorous safety process. It takes a long time. You have to check every single little thing. And here it's not make good parts and fast parts, it's make some parts then safe parts. And so NASA's basically demands that you certify that everything is safe, nothing will fail, right? And the problem is, and this is essentially what you say when you say just start cutting,
Right.
there's no way to know what's going to fail, right? Like you can fix everything and still miss what's going to fail.
Yeah.
And so in the time it would take, like they estimated, I think 3 years to get, everything certified to be safe. They could have built 4 iterations of the airplane.
Right.
And paying the salaries of all of those people to take all of that time to build that airplane, it would have literally been cheaper and had a higher likelihood of outcome to make a safe airplane to go through 3 iterations. Even if you crash the first 3, as long as nobody's in the airplane, this was unmanned. So it was literally like we did the math, and it was cheaper to build them fast and crash them and fix whatever breaks than to try and make it safe, get to year 3, put it up in the air, and almost assuredly crash anyway.
Yeah.
Right.
Yeah.
And I think that's what you get at. Like, no matter how optimum you think that part is, when you put it in the machine, there's going to be a problem.
Right.
And you may have caused that problem by trying to go too fast.
Yep.
And in taking all of that time to optimize your program, you didn't make any parts.
Yep.
And you would have had more parts and had a more reliable process and even had a faster part if you had just started cutting. Right.
Exactly.
Yeah.
Exactly.
So I think that's the good parts, then fast throughput is what we're calling it now. Mantra, right?
Yep.
And the lesson there, I think, is to try and apply that just about everywhere, right? Like focus on quality first. And if I could tie that back to a previous episode I did with Miguel, like the good parts thing is about reducing variance.
Right.
It's about, and then once your variance is low, you can afford to go faster.
Yeah. Yep.
If you try to go fast with high variance, then that variation is going to screw your process over.
And it also lets you, like getting more granular with it, it lets you really understand what the process looks like and where you can squeak out time. Cause it's like, there are cases where it's like, well, I could rough this faster. It's like, but roughing is 5% of this part. So roughing 50% faster gets you nowhere.
Right.
It gets you somewhere, but it's like on your what is it? Your Pareto chart or whatever. It's like, it's just a low impact thing. And there are assuredly lower hanging fruit unless you nailed it. But it's like, I could probably, I could probably finish one of the ones that we always encounter. That's shooting fish in a barrel a lot of the time is just like approach feeds, you know?
Right.
If you're like picking up and going down a lot, like switching those from like, 50, 60, like when you're just not quite sure, like when you're like, know that once you know you're not ever going to hit anything, it's like, 200 inches a minute. And you're just like slamming down. And that makes a big difference. Surprisingly.
Yeah. So I think the idea there is you just don't know what you don't know.
Correct.
And it's better to find what you're going to stumble over than to try and predict it and compensate for it.
Yeah.
Yeah. So good parts, then fast throughput. That's the way to structure a reliable system, whether it's making chips, putting out quotes, building airplanes, or designing your shop's overall throughput system.
Mm-hmm.
Cool. When are you going to get a good parts, then fast throughput on your hand tattoo?
On my hand. Maybe October.
On your knuckles? October.
Yeah.
Okay.
Yeah. We'll see.
If there's time while you're filling in the head tattoo.
Yeah. I kind of want to get a guillotine tattoo, guillotine tattoo.
Like a picture of a guillotine?
Mm-hmm.
Okay.
Yeah.
Cool.
No reason.
Cool.
Yeah.
All right. Well, thanks for hanging out with me, Zap.
Yeah.
Let's go get you some tea.
Yeah. Cool.
Bye, guys.